formation of the solar system. Well, it began about 4.5 billion years ago, when a part of a giant molecular cloud collapsed due to its own gravity. Since all objects with mass are gravitationally attracted to all other objects with mass in the universe, gravity tends to play a dominant role in the formation of celestial objects such as stars, planets, and galaxies. The vast distances between stars are not empty. Many areas are occupied by enormous clouds of gas and dust. Gravity acts on these clouds in various ways. Sometimes sections of the clouds become more dense than others and begin to attract more gas and dust by virtue of their gravity. Eventually, a portion of a cloud can become so dense that it collapses under its own gravity to become a nebula. Eventually, a nebula, which is the birthplace of stars, can become so dense that it begins to perform nuclear fusion. This is how a star is born, and it is how our star, the Sun, was born. This image was taken by the Hubble Space Telescope. It shows stars forming out of an enormous cloud of gas and dust that is about 6,500 light years from Earth. In the early solar system, the area now occupied by the planets was filled with hot gas, dust, and rocky objects. These materials collided with each other and often stuck together in a process called accretion. As more particles stuck together, they grew larger and collected even larger particles and chunks of molten rock due to their diameter and gravity. This process eventually resulted in the formation of the 8 planets in our solar system. So right here in this picture is an artist's interpretation of what the solar nebula may have looked like. The planets would have formed out of the disc-shaped material surrounding the Sun. And finally, the Earth. At the end of the planet-forming period, the area now occupied by the planets had cooled and cleared of much of the material that made up the solar nebula. However, the planets were not done evolving. In this period, about 50 to 100 moon-sized objects occupied the inner solar system. These objects often collided. It is believed that one such object collided with the Earth, and the leftover material formed the Moon. Prior to this period in the solar system's history, the region where the Earth formed was too hot for water. From this model, it was unclear to many astronomers how Earth gained its water. To solve this mystery, astronomers carefully investigated other objects in the solar system that might explain Earth's water. Eventually, astronomers found a number of water-heavy asteroids and comets in the asteroid belt. Astronomers reasoned that if more such objects existed in the early solar system, a collision with an asteroid or comet likely delivered water to planet Earth. I always wondered how water got on Earth.